Hi, my name is Divya. I right now work at a company called AST SpaceMobile, and basically we've launched satellites into space so that our cell phones can communicate with satellites instead of cell towers. Have you all seen cell towers around y'all? So do you all know how our phones work with those cell towers? Basically, right now, our cell phones connect to cell towers depending on wherever we're traveling. It connects to the closest cell tower that we have. So what our company has done is we've launched satellites so that our phones directly connect to those satellites and then we transmit data via that. Can anyone tell me the disadvantages of having cell towers? Okay. But also, one of the bigger problems is when we have bad weather conditions, cell towers might have problems. And also, for example, in remote areas, where, for example, when you go trekking and when you go into forests and all, you lose cell connectivity. That is where most of the time people have emergencies. So that is why our company ventured into space, because these blockages don't happen over there. So that is what our company is doing with space. But there are a lot of other ways that we can use space, because out of the entire universe and galaxy and everything we have, we've maybe studied a very small part of it. Have you all seen this movie called Mission Mangal? Yeah. So what was the point? What were they doing in Mission Mangal? Okay, correct. They wanted to study the presence of water, if there's life, and if basically what other planets are habitable for us in case we lose Earth. But so then that is just Mars. Now we're studying the moon. There was this huge thing where people went on the moon, and it's still one of the biggest achievements of Earth and US and India.
One question.
Yes.
Satellite is not for the cell tower.
Yeah. This satellite was built by our own company and it's called BlueBird. Yeah. So we launched 5 satellites into our Earth's orbit. So this launch actually happened almost a month back on 12th September. And these satellites are mostly going to cover US. So now that is our market where we're working, and that is going to give us. And also y'all would have noticed when y'all travel in flights, you'll have to keep your phone on flight mode, so that your phone signals don't interrupt with whatever data is being transmitted for the flights. So using these satellites, because they're connected to space, it's not going to hamper anything that happens between the flight and the ground station where they communicate. So you will also be able to use your phones in aeroplanes safely.
The satellites you launched are lower Earth orbit.
Yes, they're in lower Earth orbit. All 5 of them. And we're the first company to do that. So basically, so this is what you can use aerospace for. You use it to study other potential life, how much other planets are habitable. You can also come to know the past about planets, because then you'll find water. Yes, conspiracy theories about aliens. And then you can figure out, was there life earlier? Was there life now? How does the solar system and other planets and what they go through? Because if you are one solar system, anything that happens in other planets, there is a very high potential that it will also affect your planet. So, for example, we just had an asteroid that was going to hit Earth, but it missed. So you study other planets, and then you also understand how planets, stars explosion, everything. You need to study all of this to be aware about what is happening, what can also happen to your planet. So that is why we're so interested in capturing images of, for now, Mars and the Moon, to understand everything better. But that is why aerospace is such a huge field, and that is why there are so many entry points that you can get into. My company is a very small company, which just came up as an idea. So then even y'all can have a lot of ideas, which y'all can turn into huge potential companies just because y'all are interested in aerospace. And studying space basically. So for me, I did my bachelor's in electronics engineering, and I wanted to get into electronics because I'm basically interested in technology, whether it's your cell phones, or earlier that time I was also interested into cameras, but yeah, now cell phones, and now aerospace, obviously, since that is my main domain that I work in. So when you study technology, you study one technology and you don't realize that one technology can be used in almost every field present, because the basis of everything and the basis of everything that you all are studying, whether it's microcontrollers, sensors, everything, this will help you enter into literally any field there is, even aerospace, because I've also basically just done electronics engineering. And all projects and extracurricular projects that you work on, these give you a much better practical understanding. For example, when you all go into college, you all are going to have your group projects and everything, and you might not be able to put in your entire time to understand how things work, but at your age and the projects that Mr. Shah has told me about, you'll already have this real cool insight into things, and you'll want to understand why things work. So this is something that is really good for y'all, and that will be useful in your future as well. Then, so after my electronics engineering, I worked in a company called John Deere, where basically we made autonomous vehicles, and in that also, we had one GPS receiver that is mounted on tractors and everything, which communicated with a satellite. So from that satellite, we got images of farmland. In US, farmlands are huge. They're not like Indian farmlands where everything is a little relatively small, but those farms are huge. So we got clear pictures and of farms and everything. And from that, we could help decide what route your tractor is supposed to take, so that it's basically self-driven. Nobody needs to sit in the tractor and drive it. Everything was autonomous. So in that also, we use satellites for capturing images. So a tractor company is using satellites. Would you all have ever thought about that? Yeah. Then after that, I went for my master's in Singapore. And over there, I studied another field. But everything was still basically the same because it was tech. So learning microcontrollers, sensors, programming. This is the foundation of everything. After Singapore, then I came back and I got my job. I work in Hyderabad for this satellite company, where currently, even when you program satellites, so for example, now our satellite has launched, but these satellites need continuous monitoring, no matter where they are. So even in monitoring, these satellites go through certain steps. And according to those steps, so for example, when a satellite is launched, there is no use for its wheels at that point. So only after it reaches a certain stage, do you deploy its wheels, and then you get your sensor information from those wheels. So you have to sit and monitor and design this program for your satellite so that, okay, now it has reached this step, now it needs to take this action. This is basically your if states, your if iterations or your states, and you see which state you're in, you start launching your sensors, you start collecting data, you start taking actions based on that. So this, and also based on these sensors, we perform hardware testing. So no matter what scenario or whatever data your sensors collect, what is the most abrupt reaction that you possibly can get so that you program against it. Because you, yes. I use MATLAB and Simulink, which gets converted into C++. Have you all used MATLAB Simulink? No. Okay, so MATLAB Simulink is basically a little easier version of C++ because you code in that and then you just convert it into C++. Mostly that. And then when we, even with our satellite, we get continuous feed, we can see our surroundings. We see writing whenever you're writing code, and then when you actually come to test it, you have to check it from each and every possible scenario to make sure, because everything affects our coverage onto Earth. So we need continuous 24/7, 365-degree monitoring about everything that is going on. So yeah, space is a very, very less studied field, and that is why a lot of there are good courses for astrophysics, aerospace engineering, aeronautical engineering, basic engineering like electronics engineering and everything also, electronics and telecommunication. These are all good fields where you can study and learn everything that is required for space. And personal interest, of course.
Yeah.
Yes.
So this BlueBird thing, how is it different from its Starlink satellites?
So Starlink satellites are trying to do something very similar to what we have done, but Starlink requires you to buy your own device to communicate. With our BlueBirds, the phone you have currently is what you use. So you won't have to do anything. It will be a service provider that will directly connect you all to satellites. So you all don't have to change anything or buy anything extra. 4G, 5G, everything is available.
So it's like a satellite cheaper to use or the tower, which is cheaper to use.
For now, I think our satellites might be a little pricier because we're giving 100% coverage literally everywhere. Even if you're deep within the ocean, you will have coverage.
Oh.
Yeah.
Do you have an app for it?
No, you don't need anything additional, no app. Just how you're using your phone right now is how you'll use your phone then when we come to India.
So I have two questions. What powers the satellite?
They have their own pre-installed batteries because, yeah.
What is the battery? So it has solar.
Yes, it has solar panels also. It has a lot of microns, which basically help with the solar energy absorption. So even when you launch your satellite, you have to send it in as small as space as possible. It then goes into space, and once it has reached its position, it opens up so that all its arrays of solar power and everything, they can be spread across, and then you get maximum absorption because maximum surface area. Sorry? We launched it from US, Florida. SpaceX has their ground over there. We launched it from the SpaceX ground. Yes. So, like I told you, there are certain states that need to be monitored, right, when you launch a satellite, because then depending on those states, you instruct sensors and their actuators to start recording information. So I worked on a part of designing those states. So according to states, then sensors get activated.
What kind of sensors do you use in that satellite? Let's say, on this, in the DIY particularly, there are sensors and all, but in your what kind of sensors they use?
So for me, personally I've worked on, there is this actuator called reaction wheel. So basically it'll tell you what speed you're moving at, what torque is getting collected, temperature. The reaction wheel, even though it's a wheel, it'll still give you all data because you can't even let your wheels get heated up. So it has a continuous monitoring of how much voltage is going through, what is its current. Reaction wheel. Then there is something called electromagnetic torquer. Basically it helps your rods move in a positive or negative direction, and then magnetometers collect the torque information based on that. These are all little bigger sensors. That is why I don't think you all must have used it because they're pretty huge. Then we also use IMU sensors. I didn't work on IMU sensors. My colleague worked on it. That's why I don't know its full form. But yeah, IMU data also was used for calculating speed and then acceleration and temperature. Temperature is a requirement for all sensors to make sure that for example, when you're working in space, you can't have anything go below survivable temperature and above survivable temperature. That is why temperature is continuously monitored in there.